Echo. Morning.
Yeah, this is the day that Lord has made for us. All right. So we were focusing on MPLS traffic engineering. Now we are going to the technical part of it. We had a lot of stories about traffic engineering. I'm going to do slight alteration to the story to make it more technical. All right. So there will be some sort of commands also I want to introduce, and I'm going to explain why those commands are and so on. Right, when we talk about MPLS, you see, we got 1, 2, 3, 4, and 5. We got 5 routers here. We got 5 routers here. And earlier when we did MPLS, we were just allowing LDP labels to be generated by MPLS dynamically. We did not set any range of label, but there is an option where you can say the range of label that these routers can use. See, I'm not saying it is a mandatory one, an optional one. I remembered yesterday that I did not tell about this in any video, any class. We can specify what range of label, usually label ranging from 16 to 65535. Sorry, it's 2 to the power of 20, no? So starting from label 16 to 2 to the power of 20, that million labels are allowed to use by each router. And you saw sometime the label given by this router, this router, this router, this router, this router are same for that particular network. And we also saw that it is not a problem. It is okay to have same label for a particular network. There is no problem. There's no problem if to reach 5.5.5.5 label 23, 23, 23, 23 given by all this router. If all the router gives the same label for 5.5.5.5, it is okay. We saw that. That won't conflict in any manner. That won't conflict. It is okay. But sometimes some people wants to see from which router this label is coming. When we trace route, by seeing the label, they want to say this is coming, this is the label given by router 3. So what you can do is you can say router 3 MPLS. In router 3 you can say MPLS label range maybe 300 to 399. Likewise, I'll go to router 4 and say label 400 to 499. So only from that 100 labels you will see in MPLS binding table. You will see only those numbers between 400 to 499 for any network in router 4. You will not see anything other than starting with 4. Likewise, from router 3, only label ranging between this and this you will see. I want you to try this out in your next lab that you will do in your home. Label range. Note down this command, MPLS label range. So you are telling MPLS use only the label between this range. Now, did you understand this? What I spoke? Shall we go to next one?
Yeah.
Nice. Now, let's go to traffic engineering story. So the reason why I showed you here this labels range command, one is people use it sometime. So you should not be ignorant of this. You need to be aware of this. Secondly, in MPLS traffic engineering, I want to use this certain range of labels to show you some outputs which will make you understand the traffic engineering better. Fine. So let's take one topology like this. This is what the topology is going to be in our lab, the first lab of MPLS traffic engineering. I'm going to take like 1, 2, 3, 4, 5. Or let's keep it simple. 4. Now this is R1, 2, R3, R4. We are going to have traffic engineering tunnel between 1.1.1.1 to 3.3.3.3. That's our aim. We want to have a tunnel, a traffic engineering tunnel. Now, for router 1 to reach 3333, you have two paths, via router 2 and router 4. But the bandwidth on this link is 1 meg. The bandwidth on this link is going to be 2 meg. This is what I'm going to configure to make it unequal. If it is serial link, you know the default is 1.5 meg. So I'm not going to use serial, I'm going to use gig Ethernet. And I'm going to configure 1 meg on this path, another path with 2 meg. So what OSP will do, it will take this as the bandwidth, calculate the cost. And the cost of going via router 4 is going to be cheaper than the cost going via router 2. Because you know very well, more the bandwidth, cheaper is the path, better is the route. So now OSP is going to use only this path. Fine. And when we enable traffic engineering by typing this command in the global mode, make sure Ceph is enabled. And we all know when we started MPLS class, we saw that IPCEF is enabled by default. You don't need to worry about that. But if in case disabled, put this command, enable it. That is very important for MPLS. Next, we need to say MPLS traffic engineering tunnel. This is the important command to enable traffic engineering feature on router. By default, this is not enabled. We have to. Yeah. So this command enables traffic engineering service on your router. Now let's say that 1.1.1.1 is an application and 3.3.3.3 is another application. Whenever this application from this computer tries to reach the remote application in this computer, we want it to go via a path whose bandwidth is, let's say, 512 KB. 512 KB. So I want a reservation of 512 kilobits. I want to form a tunnel between these two paths. Sorry, between these two applications or running on two different computers and different locations connected via a provider edge router. So this is same customer connecting through VRF. I'm not going to get into VRF in the initial stage. We have done those things. I just want to touch the traffic engineering part initially. Later we will mix all those VRF concepts with multiple customers. Initially, I'm not going to have any VPN, no layer 3 VPN. We have a computer with an application running here and the client application running here on the remote side 333, and we want this to go via a tunnel which will guarantee bandwidth of 512 KB or guarantee 1 meg. It's up to you. Just, for example, I'm thinking, let's say how to do this, right? So what happens is when we say let's make it as a 1 meg, so that it will be easy for me to write. I don't want to write 512 KB, 512 KB, 1 meg, easy. So what happens, as we already learned, there is a path message. This is what I want to explain you in detail now. Now R1 will be sending path message via all the paths. So this is the one recommended by OSPF, because OSPF will pick this as the best path via router 4. So first it will check this path. Actually, it will be checking simultaneously both the paths, but let me explain the below path now. RSVP sends a path message. In that path message, it will say, hey, I'm looking for 1 meg. One meg of bandwidth. Now, if R4 has that bandwidth available, don't see this 2 meg and say, hey, R4 will definitely have. Don't think that link between R1 and R4 will always have. No. What if there are many other traffics already using the path? Now let's assume it is available. 1 meg is available. The path message is going and saying, hey, I want 1 meg. Now, if this link between R1 and R4 has that 1 meg, then R4 will keep it standby and send the same to R3, 1 meg RSVP path message. So R4 is sending a path message by holding this 1 meg in a standby. Standby is very important. It is holding that 1 meg. And meanwhile, it is also sending to R3 saying, hey, do we have 1 meg between you and me? R4 is sending to R3. Now R3 is the final destination. R3 is the destination of the tunnel. And R3 says, yes, I do have 1 meg. Then by keeping that 1 meg in standby, that standby is very important. Router 1 and router 4 is having that 1 meg in standby. Now router 4 and router 3, that is also having that in standby. By keeping that in standby, R3 sends a reserve message. I reserve 1 meg for you. RSVP reserve message is coming. Now R4 is also sending R1. Yes, we do. Reserved 1 meg. After which the tunnel is going to be established and traffic will go from here to here. Right. So that standby and reserve is important. Path message, it goes hop by hop. If one hop, say for example, this don't have that bandwidth, then this guy who was keeping in standby will release it. No more standby. It will release it. It won't be keeping blocking it anymore. Now this one will come up with the reserve message successfully because this one no one was using. OSPF was not recommending this path, but it was there in the database, and RSVP's path message went this put in standby because the bandwidth is available. This was putting in standby because the bandwidth is available 1 meg. No one is using it. So reserve message comes successfully here and the packet goes this way. So the tunnel is established via this path because this was not having enough bandwidth to support the tunnel. The tunnel demands 1 meg. But even though the link has got 2 meg, the usage, the real-time traffic is heavy. Real-time traffic is consuming out of 2 meg, 1.5 meg is already a consumption. Already it is being consumed. So R4, R3 don't have any option to keep anything like 1 meg to be in standby. So R4 informs the other side to R1 that sorry, the downstream is not able to hold the bandwidth, don't have the bandwidth. So this is stored down, the standby is removed and given for other traffics. Now this is what successfully coming with reserve message. And now a label for this new path is also given by R3. When a reserve message comes, it comes with a label. Okay, see, I'm giving you a path, I reserve, I have the path that you asked for, and if you are coming, you use this label, right? So using that label, the traffic goes. And that label will change time to time when you're tearing down the tunnel and re-establishing the tunnel. Don't expect the same label always. The label will change. So the standby and the reserve, we have seen them. Now let's see some configuration commands. For that, let us go to the lab. All right, let us put some routers here. As we discussed, we are going to have 1, 2, and 3, and 4. So I was having like this in the diagram, so let me arrange same matching with the diagram. All right, so I'm going to just use this to loop back, and in between R1 and R2, it is going to be 10.12.0.0/16. And This is going to be 14. 23 and 43. Yeah, so the interface names are like this. Now on router 2 and router 4 also we got the loopbacks. That's not necessary, but just for the sake of OSPF, I'm doing this so that I can pick it as router ID. Even MPLS will use the loopback interface as the router ID, and the MPLS router ID should be reachable. This is all we learned in the beginning days. Now let us start all the router and put those configurations that are necessary using a notepad. So I'll put configurations like IP address, OSPF, and MPLS. Traffic engineering I'll do directly on the command line so that it will be more clear for us. So notepad. Enable config key interface loopback 0 IP address 1.1.1.255.255.255 IP OSPF 1 area 0 interface F0/0 no shared IP address 10.12.0.125.255.0.0 IP OSPF 1 area 0 interface F0/1 no shared IP address 10.14.0.125.255.0.0 IP OSPF 1 area 0 and the write to memory. Okay, let us also enable MPLS. MPLS IP. You cannot enable MPLS on loopback. You know it very well because it's a logical interface. There is no label distribution there possible. And done. Select all. Copy. Copy. I paste this on router 1. So router 1 has got OSPF and MPLS. Let us verify that by typing this command show MPLS. First of all, show IP OSPF interface brief. You can see OSPF command. 3 interfaces are running OSPF. I'll also add this, and then another show command, show MPLS interfaces. These are the 2 interfaces that runs MPLS. So this also I'll add to the notepad so that every time you don't need to type. Done. Okay, now let us move on to the second router's configuration in the template. This is for router 2, so 2. F00 will have 10.12.02. F01 will have 10.23.02. That's it. I'm going to copy all and paste it on router 2. And you are seeing the outputs. Look at this. We got 3 interfaces of OSPF and 2 interface of MPLS LDP. Now I am also expecting MPLS neighbor. OSPF has come up. MPLS neighbor will also come. See, MPLS also come up. Wonderful. Now let us move on to router 4 and router 3 configuration. Router 3 will have 3333 here, and F00 will have 23.3, and F01 is going to have 43.3. Router 3. Yeah. So SPF has come. I'm also expecting MPLS neighbor now. MPLS neighbor with 2222 should come. Okay, it has come. Now let us move on to the last router. 44444. Wait, let's do one more. We learned a new command really. Remember that range command? Let me also put that. I'm going to say, hey, you need to use MPLS label range um, between 400 is the minimum, 499 is the maximum. So this router will not generate any other label other than this range. Okay, so we should have done this early, but we didn't do. Now at least we do it now. And then F00 will have 14. We should have done these things in the other routers. The range command I forgot. That's okay. We can do it later also there. Now focus on this. R4 F01 will have 43.4. Alright, select all, copy, put this on router 4. Okay, so the range command is taken. I am expecting two neighbors now, router 1 and router 3 as the LDP neighbor. OSPF 2 neighbor, so your OSPF 1 neighbor has come, router 1. Router 3 also will come. Okay, LDP has come. That means router 3 also should come. OSPF 33333 neighbor and LDP 333 neighbor.
On router 3, you configured 1042 J, not 1043.
But I'm seeing label now. Sorry, MPLS now. I don't think I made a mistake. Let us check on router 3. Show IP interface brief. Okay, 42, you're right. You are right. Then it is forming neighbor like this. Okay, show IP interface brief here. Yeah, here 43. So the neighborship would have formed like this going around. So let us go to router 3 and change it. Interface F0/1, shutdown IP address. IP address is 10.43.0.3.
3. Yeah.
Thank you for this. So, oh shit. Okay, now the LDP neighbor has come. Everything looks good. Nice. Now, what is next is I would like to show you the labels now. Show MPLS forwarding table. The local labels. I gave a range. Okay, here you see there's a label range 402. Router 4 has given a label. See, I'm showing you in router 3. Router 3 has got two paths, two equal paths. One via router 2, the label is 16. The other via router 4, the label is 402 because we set range, you remember, on our 4. If you check show MPLS forwarding table, all the local labels, if you check, it is 400. Now let us also do this range command on every router to have a more hygienic look. MPLS label range 100 to 199. We need to refresh MPLS. Later we'll do it. I'll first of all go to row 2 and 3 and change the range. MPLS label range. Minimum is 200. Maximum is 299. And an R3. MPLS label range. Minimum is 300. Maximum is 399. Now let us clear MPLS IP. Start. What? Or I'll do one thing simple is no MPLS IP. MPLS IP is the command I need to put. Meanwhile, I'll go to router 3. Sorry, router 2 to the same. No MPLS IP. MPLS IP. I'm not hitting enter. And then R1 also. That. Now R3 is done. R2 is done. R1 is also done. So if you check now the labels, you will be easily knowing who was given what label. Show MPLS forwarding. You can see that to reach 3333, router 2 has given 201. How do I know 2? This number shows. Not only that, here the gateway shows. Not only that, the exit interface of router 1 F00 connects to 2. And this is given by router 4. So it's very nice to see with range. Let's check it in router 2. Show MPLS forwarding. You can see all the local labels are starting with 200, 204, 203, like that. And router 3 will have all 3333 starting. All right. Okay, fine. Now it's time for traffic engineering to enable. Let's enable traffic engineering. As I said earlier, you had to enable the traffic engineering feature in the global mode. The command is MPLS traffic engineering tunnel. So let me start from router 1. MPLS traffic engineering tunnels. Boom. This enables the traffic engineering feature. Now, I repeat this. MPLS traffic engineering tunnels. MPLS traffic engineering tunnels. MPLS traffic engineering tunnels. Okay. So this feature, traffic engineering, should be enabled before you do anything related to traffic engineering. Next is I have to go to OSPF and say, hey, OSPF, you need to support traffic engineering. It will use opaque LSA. I'll come to those OSPF part of traffic engineering later. Let us now get into the tunnel. I would like to form tunnel between R1 and R3. So the configuration goes like this. On R1, interface tunnel 1 or 0, whatever. I'm saying tunnel 0. IP unnumbered loopback 0. I'm using loopback as the source. And then,
Okay.
yes.
So we configure this. We are doing this configuration IP unnumbered loopback 0 because this tunnel will not have any IP address assigned, is it?
Not only that, whenever the tunnel speaks, it will use the loopback address as a source address.
Okay. Okay.
You see, we want tunnel to be between 1111 and 3333, right?
Correct.
So I'm saying loopback 0 is a tunnel source. That's the other meaning of this. So I'm not only saying
Yeah.
I don't want to give you an address copy from loopback. I'm also saying you are the loopback. In tunnel is 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 generated. Tunnel opening is in loopback 0 interface. And now tunnel destination is what? 3.3.3.3. And then tunnel mode is important. Tunnel mode is MPLS traffic engineering. Very important. The default mode is GRE, we all know. Now we are saying, no. This I'm doing for traffic engineering. Next. Tunnel, we need to allocate some bandwidth, whatever you commit to the customer. Let's say I want 1 meg. So I say tunnel MPLS traffic engineering bandwidth command. Okay, bandwidth command. And it is in kilobits. See, it's in kilobits. I'm going to say 1 meg, 1000 kilobits, 1 meg. Next is, I'm going to say you can dynamically decide the path. I'm saying you can dynamically decide the path. So for that, I'll say tunnel MPLS traffic engineering path option 1. You can have multiple options. Today, I'm not going into path options. I'm saying I have only only one option, and that also I don't have a static path to say. I just want you to. I don't have an explicit path to say. I just want you to decide by yourself dynamically. Done. Next is I'm also going to say, in case if you decide to go via router 2, if that router 2 fails, automatically reroute via router 4. Don't ask me. Don't interrupt the traffic flow. Just automatically you shift it to the better route. For that, you say traffic engineering auto route announce. Boom. So this is for uninterrupted failover. No interruption. Now, I would like to type this command to show what has been configured and what is the current status. Show MPLS traffic engineering tunnels. As of now, the tunnel is not found. Listen. As soon as I say, you see, it is clearly taken the host name R1 and the tunnel 0 interface T0 as a name. And this is the tunnel 0. Destination of the tunnel is 3333. And the bandwidth that is needed is 100 meg. Okay, now the tunnel is
1 meg.
created. Sorry, what did he say? 1 meg.
1 meg.
1 meg. What did he say? Sorry.
You said 100 meg.
100 meg. Okay, 1 meg. 1 meg. Okay, this is the time taken, and but the tunnel is not established. Okay, so now let us go to router 3 and configure the tunnel. Interface tunnel 0, IP unnumbered loopback 0. Tunnel destination is 101.101. Tunnel mode is MPLS traffic engineering. Tunnel What is that? Tunnel, we need to allocate bandwidth, no? So tunnel MPLS traffic engineering bandwidth is 1000 kilobits, that's 1 meg. And then tunnel needs to dynamically discover the path. So I say traffic engineering path option, dynamic. Tunnel MPLS traffic engineering auto route
Auto route.
announce. Okay. So I have
Jay?
configured.
Yeah, we are not writing the explicit configuration.
That we'll do later.
Okay,
Explicit
sure.
path option and all. I have to teach you a lot of other things before I take you there.
Yeah, okay.
So I'm just teaching you the ABC of traffic engineering now. We have a lot to discuss.
Okay, but when we started the traffic engineering session, we also you talked about RSVP as a command, but we did not use that RSVP command in this configuration.
We will be enabling under. When did I talk about RSVP command?
In the last session,
See, when I enable
uh,
traffic engineering, RSVP is the default command.
sorry, say that
When
again.
I enable traffic engineering, RSVP is the default protocol.
Okay, okay, got it.
Okay, so now if you want, I can capture some packet and show you, but the tunnel is still not established. Let me show you. Show IP interface brief. You got the tunnel interface, but it is down. The reason is in the path, every router should support RSVP. In the path, every router should have some bandwidth ready for giving, ready to give to whom? To RSVP that comes. So that may be the command that I might have explained you in the previous class. That comes under the interface. So right now when I say show MPLS traffic engineering tunnel command, still you can see it did not see any path, the link. So let us go and enable it. Interface F0/0 MPLS traffic engineering um, tunnels. That's it. No.
No, we have to start with tunnel, right?
Interface F0/0 IP RSVP. Yeah, IP RSVP bandwidth. IP RSVP. I don't know why. Okay, correct. Bandwidth only. Bandwidth. Boom. This is to say, hey, interface, you should give whatever RSVP has. But bandwidth, I can also set limit. What is the maximum? What is the minimum? I'm not getting into that now. Let's see the default. I was talking about this. Now I remember what you said. This is what I was talking about in the previous class. Interface F0/1. Again, I say same thing. This need to be repeated on every interface on every router in the path. On R1 also I say IP, not MPLS traffic engineering tunnels, and then I need to say interface range F00-1, and then I need to say IP RSVP bandwidth. Boom. I repeat the same on R2 and R4. So do show history, do show this, and these are the commands. I put this one on router 2. And router 4. And then router 3. And then router, whatever, I'm repeating again, it's fine. Now, I have reserved some bandwidth. I want to show you that. Show IP RSVP interface. You see, 75 meg of bandwidth is by default given to RSVP, given to RSVP as of now. Now, let's go to router 3 and check whether we have that interface up. Still not it. You cannot